Welcome to lesson 3 of the set theory series. In lesson 3, we'll be talking about the types of set. In our previous lesson, we talked about the membership and cardinality. That was in lesson 1. And lesson 2, we talk about the roster form and the set builder notation. If you want to follow up on those lessons, please check out the link in the description of this video. Please don't forget to subscribe to this channel so that you don't miss out on any future video that we will be uploading. Without much ado, let us begin. Okay, we will be talking about the types of set. So we'll begin with the empty set. An empty set is just simply a set that does not have any member. Okay, so we say a set which does not contain any member. It is also called a void set or a null set, and is mathematically represented as this: set A equals, within a pair of braces there are no member, so that is an empty set, or it can be represented this way as a null set. Okay, so this is an empty set. And the next one, we will look at the singleton set. A singleton set is a set which contains a single member. If you have set B equals 3, for example, this is a singleton set because it has only one member in that set. So that's a singleton set. Then the next one is a finite set. A finite set is a set which consists of a definite number of members. So if you have set B, for example, equals to this 1, 2, 3. All right, these are 3 members. You can count the number of members of this set. So that is a finite set. Or it could be this: set C equals 3, 9, 27, with 3 dots up to 125. Okay, this is also a finite set because we can count the number of members of this set. Then let's look at the infinite set. An infinite set is a set which consists of an infinite number of members. For example, if we have set A equals 1, 2, 3 with 3 dots. Okay, this is an infinite set because it consists of an indefinite number of members, an infinite number of members. Here we cannot count the number of members of this set. All right, so it can be written in this way. So this is an infinite set. Or in set builder notation form, this could be written as X such that X is a natural number and 1 is less than or equals to X less than infinity. All right, this is an infinite set. Equivalent sets. Okay, equivalent sets are 2 sets with equal cardinality. If you have set A equals 1, 2. 2 members. Set A has 2 members. And set B also has 2 members. So it means set A is equivalent to set B. But if you had another set, set C equals 1, 2, A, B. Okay, set A is not equivalent to set C. Set B is also not equivalent to set C because they do not have the same cardinality. The cardinality of set A is 2 and that of B is 2. But C, the cardinality here is 4. So they are not equivalent sets. Then let's look at the equal set. Equal sets are two sets with exactly the same elements. If you have set A equals 3, 6, 9, 12, and set B equals 1, 2, 3, 4, and set C equals 3, 6, 9, 12. Okay, so for equal set, we say two sets with exactly the same elements. So set A and set C are equal sets because they have exactly the same elements. But set A and set B are not equal sets, but they are equivalent sets because they do not have exactly the same elements. But what they have is the same cardinality. So when they have a same cardinality, they are equivalent sets. And if they have the same kind of members, then they are equal sets. So set A and set C are equal sets, and set A and B are not equal sets. B and C are not also equal sets. A set, let's say A, whose elements are also elements of another set, let's say B, then set A is a subset of B. All right? So for example, if we have set D equals 1, 3, 5, and set E equals 1, 3, 5, 7. Okay, so it means set D is a subset of set E. Now the reason is all the members of set D are also in set E. All right, so set D is a subset of E, but set E is not a subset of D. Set E is not a subset of D. Now reason is set E has a member that is not in set D. So set E is not a subset of set D. A set can only become a subset if all of its members are in the other sets. All right? So there are two sets that are subsets of every set, and those two sets are the set itself. For example, set D is a subset of, so here we can say set D is a subset of D, of set D. And another set that is a subset of set D is empty set, or the null set is also a subset of D. All right, so empty set is a subset of all sets, and a set is also a subset of itself. That we should also take into consideration. Now the next one, number 8, is disjoint sets. Any two sets that does not contain any common element are called disjoint sets. So if you have set A equals 2, 4, 6, 8, and set B equals 10, 12, 14. Set A and set B are disjoint set because they do not have any common member. Now we look at now the proper subset. If A is a subset of B, but they are not equal, then A is a proper subset of B. Let's see an example. If you have A equals 2, 4, 6, and B equals 0, 2, 4, 6, 8. Okay, for example, if you have these two sets, A and B, what you see is that all the members of A are within set B, but not all the members in set B are found in set A. So in that case, set A is a proper subset of set B because set A is within set B, but they are not equal. Okay, so we say that set A is a proper subset of set B. Okay, so I hope you understand all of the different types of set and TQ. Thank you and see you in the next video.